Finding the general term or the nth term. 1. Prepare a table with row headings n and a dot sub n where n represents the domain set of positive consecutive integers and a sub n represents the term that corresponds to the elements of the range. Take at least 5 pairs. 2. Get the first difference. 3. Form two equations by using two pairs of number. A sub n plus b equals a sub n. 4. Solve for a and b. 5. Substitute a and b in the general form. 6. Check. Example 1. Find the general term of the sequence 5, 12, 19, 26, 33. Solution. Step 1. Step 2. Get the first difference 5, 12, 19, 26, 33. Step 3. Substitute. The sub n plus b equals a sub n. If n equals 1 and a sub n equals 5, the times 1 plus b equals 5, a plus b equals 5 equation 1. If n equals 2 and a sub n equals 12, the times 2 plus b equals 12. 2a plus b equals 12 equation 2. Step 4. Solve for a and b. 2a plus b equals 12. Equation. 2. A plus b equals 5. Equation 1. B equals 7. Subtract equation 1 from equation 2. Example 2. Find the general term of the sequence 1, 3, 6, 10, 15 so on. Solution. Step 1. Prepare a table. Step to get the first and second difference. Solve for b. A plus b equals 5. 7 plus b equals 5. b equals -2. Substitute 7 or 8. E. Substitute a and b in the general form. A sub n plus b equals a sub n. 7n minus 2 equals a sub n. Therefore, the general term of the sequence 5, 12, 19, 26, 33, so on is a sub n equals 7n minus 2. F. Check. A sub 1 equals 7 times 1 minus 2 equals 7 minus 2 equals 5. A sub 2 equals 7 times 2 minus 2 equals 14 minus 2 equals 12. A sub 3 equals 7 times 3 minus 2 equals 21 minus 2 equals 19. A sub 4 equals 7 times 4 minus 2 equals 28 minus 2 equals 26. A sub 5 equals 7 times 5 minus 2 equals 35 minus 2 equals 33. Step 3. Form 3 equations by using 3 pairs of the numbers from the table. A sub n squared plus b sub n plus c equals a sub n. If n equals 1 and a sub n equals 1. A times 1 squared plus b times 1 plus c equals 1. A dot plus b plus c equals 1. Equation 1. If n equals 2 and a sub n equals 3. A times 2 squared plus b times 2 plus c equals 3. For a plus 2b plus c equals 3. Equation 2. If n equals 3 and a sub n equals 6. A times 3 plus b times 3 plus c equals 6. 9a plus 3b plus c equals 6. Equation 3. Solve for 8, b, and c. Subtract equation 1 from equation 2. For a plus 2b plus c equals 3. A plus b plus c equals 1. 3a plus b equals 2. Equation 4. Subtract equation 2 from equation 3. 9a plus 3b plus c equals 6. 4a plus 2b plus c equals 3. 5a plus b equals 3. Equation 5. Subtract equation 4 from equation 5. 5a plus b equals 3. 3a plus b equals 2. 2a equals 1. b equals 1/2. Solve for b by replacing a with 1/2 in equation 4. 3 times 1/2 plus b equals 2. 3/2 plus b equals 2. b equals 1/2. Solve for c by replacing a with 1/2 and b with 1/2. In equation 1, 1/2 plus 1/2 plus c equals 1. C equals 0. E. Substitute a, b, and c in the general form. A sub n squared plus b sub n plus c equals a sub n 1/2 n squared plus 1/2 n plus c equals a sub n 1/2 n times n plus 1 equals a sub n. F. Check. A sub 1 equals 1/2 times 1 times 1 plus 1 equals 1/2 times 2 equals 1. A sub 2 equals 1/2 times 2 times 2 plus 1 equals 1 times 3 equals 3. A sub 3 equals 1/2 times 3 plus 1 equals 3/2 times 4 equals 6. A sub 4 equals 1/2 times 4 plus 1 equals 2 times 5 equals 10. A sub 5 equals 1/2 times 5 plus 1 equals 5/2 times 6 equals 15. Example 5. General term of a sequence. Find the general term for each sequence. Then, find the 10th term for each. 8, 7, 11, 15, 19, 23 so on. B. 7/2, 19/2, 31/2, 43/2, 55/2 so on. C. 1, 5, 12, 22, 35 so on. D. 1, 2, 3, 4, 5. Solution. Step 1. Prepare a table with a sub 1 equals 7, a sub 2 equals 11, a sub 3 equals 15, and so on. Step 2. Take the first difference. 7, 11, 15, 19, 23. Step 3. Form two equations of the form a sub n plus b equals a sub n. If n equals 1 and a sub n equals 7, a times 1 plus b dot equals 7, a plus b equals 7 equation 1. If n equals 2 and a sub n equals 11, a times 2 plus b equals 11, 2a plus b equals 11 equation 2. Step 4. Solve for the system of linear equations a plus b equals 7 equation 1. 2a plus b equals 11 equation 2. 2a plus b equals 11 equation 2. a plus b equals 7 equation 1. b equals 4. Subtract equation 1 from equation 2. Solve for b. 4 plus b equals 7. Substitute 4 for it in equation 1. b equals 3. Step 5. Substitute the values of a and b in the general form. A sub n plus b equals a sub n. For n plus 3 equals a sub n, or a sub n equals for n plus 3. Checking, replace n with 1, 2, 3, 4, and 5. A sub 1 equals 4 times 1 plus 3 equals 7. A sub 2 equals 4 times 2 plus 3 equals 11. A sub 3 equals 4 times 3 plus 3 equals 15. A sub 4 equals 4 times 4 plus 3 equals 19. A sub 5 equals 4 times 5 plus 3 equals 23. Thus, the 10th term of the sequence is a sub 10 equals 4 times 10 plus 3 equals 43. Solution. B. Step 1. Prepare the table with a sub 1 equals 7/2, a sub 2 equals 19/2, a sub 3 equals 31/2, and so on. Step 2. Take the first difference. 7/2, 19/2, 31/2, 43/2, 55/2. Step 3. Form two equations of the form a n plus b equals a sub n. If n equals 1 and a sub n equals 7/2, a times 1 plus b equals 7/2, a plus b equals 7/2. Equation 1. Step 4. Solve for the system of linear equations. A plus b equals 7/2 equation 1. 2a plus b equals 19/2 equation 2. If n equals 2 and a sub n equals 19/2, 8 times 2 plus b equals 19 halves. 2a plus b equals 19 halves. Equation 2. 2a plus b equals 19 halves. A plus b equals 7 halves. b equals 6. Subtract equation 1 from equation 2. Solve for b by replacing a with 6 in equation 1. 6 plus b equals 7 halves. b equals negative 5 halves. Step 5. Substitute the values of a and b in the general form. A n plus b equals a sub n. 6n minus 5 halves equals a sub n, or a sub n equals 12n minus 5 halves. Check. A sub 1 equals 12 times 1 minus 5 halves equals 7 halves. A sub 2 equals 12 times 2 minus 5 halves equals 19 halves. A sub 3 equals 12 times 3 minus 5 halves equals 31 halves. A sub 4 equals 12 times 4 minus 5 equals 43 halves. A sub 5 equals 12 times 5 minus 5 equals 55 halves. Thus, the 10th term of the sequence is a sub 10 equals 12 times 10 minus 5 halves equals 115 halves. C. Solution. Step 1. Prepare a table with a sub 1 equals 1, a sub 2 equals 5, a sub 3 equals 12, and so on. Step 2. Take the first difference. Step 3. Take the second difference. Step 4. Form 3 equations in the form a n squared plus b n plus c equals a sub n. If n equals 1, and a n equals 1, a times 1 squared plus b times 1 plus c equals 1. A plus b plus c equals 1. Equation 1. If n equals 2 and a sub n equals 5, a times 2 squared plus b times 2 plus c equals 5. For a plus 2b plus c equals 5. Equation 2. If n equals 3 and a sub n equals 12, a times 3 squared plus b times 3 plus c equals 12. 9a plus 3b plus c equals 12. Equation 3. Subtract equation 1 from equation 2. For a plus 2b plus c equals 5 minus a plus b plus c equals 1 equals 3a plus b equals 4. Equation 4. Step 5. Solve for the system of linear equations. A plus b plus c equals 1. Equation 1. For a plus 2b plus c equals 5. Equation 2. 9a plus 3b plus c equals 12. Equation 3. Subtract equation 2 from equation 3. 9a plus 3b plus c equals 12. Minus 4a plus 2b plus c equals 5. Equals 5a plus b equals 7. Equation 5. Subtract equation 4 from equation 5. 5a plus b equals 7. Minus 3a plus b equals 4. 2a equals 3. Equals a equals 3 halves. Solve for b by replacing a with 3 halves in equation 5. 5 times 3 halves plus b equals 7. 15 halves plus b equals 7. b equals negative 1 halves. Solve for c by replacing a with 3 halves and b with negative 1 halves in equation 1. Step 6. Substitute the values of a, b, and c in the general form. 3 halves plus negative 1 halves plus c equals 1. 1 plus c equals 1. c equals 0. 3 halves raised to n squared minus 1 halves n plus 0 equals n. Check. Replace n with 1, 2, 3, 4, and 5. A sub n equals 1 half n times 3n minus 1. A sub 1 equals 1 half times 1 times 3 times 1 minus 1 equals 1. A sub 2 equals 1 half times 2 times 3 times 2 minus 1 equals 5. A sub 3 equals 1 half times 3 times 3 minus 1 equals 12. A sub 4 equals 1 half times 4 times 3 times 4 minus 1 equals 22. A sub 5 equals 1 half times 5 times 3 times 5 minus 1 equals 35. Thus, a sub 10 equals 1 half times 10 times 3 times 10 minus 1 equals 5 times 29 equals 145. D. Solution. Step 1. Prepare a table with a sub 1 equals 2. A sub 2 equals 6. A sub 3 equals 12, and so on. Step 2. Take the first difference. Step 3. Take the second difference. Step 4. Form 3 equations in the form a, n squared plus b n plus c equals 0. If n equals 1, and n equals 2. A times 1 squared plus b times 1 plus c equals 2. A plus b plus c equals 2. Equation 1. If n equals 2, and a sub n equals 6. A times 2 squared plus b times 2 plus c equals 6. For a plus 2b plus c equals 6. Equation 2. If n equals 3, and a sub n equals 12. A times 3 squared plus b times 3 plus c equals 12. 9a plus 3b plus c equals 12. Equation 3. Step 5. Solve for the system of the linear equations. A plus b plus c equals 1, equation 1. For a plus 2b plus c equals 6, equation 2. 9a plus 3b plus c equals 12, equation 3. Subtract equation 1 from equation 2. For a plus 2b plus c equals 6. Minus a plus b plus c equals 2. Equals 3a plus b equals 4, equation 4. Subtract equation 2 from equation 3. 9a plus 3b plus c equals 12. Minus 4a plus 2b plus c equals 6. Equals 5a plus b equals 6, equation 5. Subtract equation 4 from equation 5. 5a plus b equals 6. Minus 3a plus b equals 4. 2a equals 2. Equals a equals 1. Step 6. Substitute the values of a, b, and c in the general form. Solve for b by replacing a with 1 in equation 4. 3 times 1 plus b equals 4. B equals 1. Solve for c by replacing a with 1 and b with 1 in equation 1. 1 plus 1 plus c equals 2. C equals 0. 1 n squared plus 1 times n plus c equals a sub n. Or a sub n equals n squared plus n. Or a sub n equals n times n plus 1. Check. Replace n with 1, 2, 3, 4, and 5. A sub 1 equals 1 times 1 plus 1 equals 2. A sub 2 equals 2 times 2 plus 1 equals 6. A sub 3 equals 3 times 3 plus 1 equals 12. A sub 4 equals 4 times 4 plus 1 equals 20. A sub 5 equals 5 times 5 plus 1 equals 30. Thus, a sub 10 equals 10 times 10 plus 1 equals 10 times 11 equals 110. Finite series. The sum of the terms of a finite sequence. A sub 1, a sub 2, a sub 3, a sub n is called finite series, and is denoted by S sub n equals a sub 1 plus a sub 2 plus a sub 3 plus a sub n. To find S sub 5, where a sub n equals 23 minus 4n, we have S sub 5 equals a sub 1 plus a sub 2 plus a sub 3 plus a sub 4 plus a sub 5 equals 23 minus 4 times 1 plus 23 minus 4 times 2 plus 23 minus 4 times 3 plus 23 minus 4 times 4 plus 23 minus 4 times 5 equals 19 plus 15 plus 11 plus 7 plus 3 equals 55. To describe the sum of the terms of a sequence, we use the summation notation. The Greek letter sigma is used to indicate the sum, then summation by equals 11. A sub 1 equals a sub 1 plus a sub 2 plus a sub 3 plus a sub n by equals 1. In the above example, I is called index of summation, n is the upper limit of the summation, and 1 is the lower limit of the summation. It is read as the sum from I equals 1 to n of a sub 1. For example, the sum of the first 5 terms of the sequence, a sub n equals n squared plus 1, can be written as 5 summation n equals 1 equals n squared plus 1. It is read as the sum from n equals 1 to 5 of n squared plus 1. To find the sum, we let n take the values 1 through 5 in the expression n squared plus 1. Thus, 5 summation n equals 1. N squared plus 1 equals 12 plus 1 plus 22 plus 1 plus 32 plus 1 plus 42 plus 1 plus 52 plus 1. equals 2 plus 5 plus 10 plus 17 plus 26 equals 60. The sigma notation evaluates the expression n squared plus 1 immediately following the sigma sign, first for n equals 1, then for n equals 2, and so on until n equals 5. Afterward these numbers will be added. That is, the expression is evaluated for consecutive numbers starting with the value of n listed at the bottom of the sigma notation n equals 1 and ending with the value of n listed at the top of the sigma notation n equals 5. Other letters may also be used. The expression summation times n squared plus 1, summation times I squared plus 1, and summation times k squared plus 1 all have the same value. Melcher works as a merchandiser in a supermarket. His supervisor asked him to create a display in which oranges are stacked in the shape of a pyramid as shown at the right. The pyramid must have 15 layers. How many oranges does Melcher need? Solution: to solve the problem, you first need to recognize that the bottom layer has 152 oranges, the next layer has 142, and so on. This means that the total number of orange is 5 summation by equals 1. I squared equals 12 plus 2 squared plus 3 squared plus 152 equals 1240. One way to find the sum is to add the 15 terms. An alternative to use 5 summation by equals 1. I squared equals 1/6 times n plus 1 times 2n plus 1. In this case, 15 summation by equals 1. I squared equals 1/2 times 15 plus 1 times 2 times 15 plus 1 equals 1/2 times 15 times 16 times 31 equals 1240. There are 1240 oranges in the stack. Check this by actually adding the number of oranges in each of the 15 layers. Activity 1. Fill in the blanks to make each statement true. 1. In mathematics, we think of a slash and blank as a list of numbers. 2. The symbol a sub n represents the blank, or the general term of a sequence. 3. The sum of the terms of a sequence is called a slash and blank. 4. To describe the sum of the terms of a sequence, we use the blank notation. 5. In summation notation, the sum of n squared for n between 2 and 7 inclusive can be written as blank. 6. In for summation by equals 1. The letter is the blank of the related sequence. Activity 2. Find the next term of each sequence. 1. 1 for 7 10. 2. For 1 for 1. 3. 5 to 8 3. 4. 0 to 8 18. 5. 4 8 16 32. 6. 2 third. 0. 2 third. 4 third. 7. 3 fourth. 4 ninth. 5 16th. 6 25th. 8. 1 49 fourth. 1027th. 28,561 256. 9. 1 half. 1 sixth. 1 12th. 1 20th. 10. 1 third. 1 fourth. 1 fifth. 1 sixth. Activity 3. List all the indicated terms of each finite sequence. 1. A sub n equals for n minus 5 for 1 less than or equal, n less than or equal 5. 2. A sub n equals n cubed minus 1 for 1 less than or equal, n less than or equal for 3. A sub n equals 3 n halves squared for 1 less than or equal, n less than or equal 5. 4. A sub n equals n plus 3 halves for 1 less than or equal, n less than or equal 3. 5. A sub n equals n raised to 4 minus n squared minus 1 for 1 less than or equal, n less than or equal 3. Activity 4. Find the indicated term in each of the following sequence. 1. A sub n equals to n plus 1 times 5th term. 2. A sub n equals n squared plus 2n times 4th term. 3. A sub n equals negative 3n plus 4 times 6th term. 4. A sub n equals n plus 2 halves times 7th term. 5. A sub n equals n squared plus 2n minus 1 times 6th term. Activity 5. Find the mathematical expression that describes the pattern. 1, 3, 7, 11, 15, 2, 2, 6, 10, 14, 3, 5, 11, 17, 23, 4, 9, 11, 13, 15, 5, -2, -5, -8, -11, 6, 5 halves, 7 halves, 9 halves, 11 halves, 7, 1, 6, 15, 28, 45, 8, 1, 7, 18, 34, 55, 9, 2, 5, 10, 17, 26, 10, 2, 6, 12, 20, 30. Activity 6. Use summation notation to represent each sum. Use I as the index of summation and begin with I equals 1. 1, 3 plus 6 plus 9 plus 12 plus 15 plus 18 plus 21. 2, 7 plus 9 plus 11 plus 13 plus 15. 3, 1 plus 3 plus 9 plus 27 plus 81 plus 243. 4, 1/3 plus 1/6 plus 1/9 plus 1/12. 5, 1/3 plus 1/9 plus 1/27 plus 1/81. Activity 7. Answer. 1. The ball is dropped from a height of 24 feet and always bounces off to 1/3 of the height from which it falls. Express the heights from which the ball falls as terms of a sequence. Write a formula for the nth term of the sequence.
Welcome to Lesson 1, the arithmetic sequence. We're going to divide this lesson into 3 parts. The arithmetic sequence, arithmetic mean, and the arithmetic series. Let's start with the arithmetic sequence. Arithmetic sequence is also known as the arithmetic progression. Take a look at this pattern. 4, 11, 18, 25. So they have common number, which is you're going to add that number, then you will get the next term. In this case, we can get that fixed number by subtracting the previous term or the preceding term to the previous term. 11 minus 4, that is 7. 18 minus 11, 7. 25 minus 18, that is 7. And this fixed number is known as the common difference. And that is denoted by the symbol small letter d. And our formula for that is A2 minus A1. Or it can be A3 minus A2, A4 minus A3, or A5 minus A4. What is A1, A2, A3? A1 is denoted by our first term. A2 will be our second term. A3 will be the third term. And A4 will be the fourth term. What if your teacher asks you, what is the 11th term? 11th term of the arithmetic sequence. And now I will introduce to you the first formula in this sequence. We have the AN formula. AN is equal to A1 plus n minus 1 d. Wherein AN denoted as the last term, A1 is the first term, N is the last term, nth term, and D is the common difference. In this case, we're going to find the 11th term. So that is the A11. Substitute the formula. A1, our A1 is 4 plus N term 11 minus 1 times D. D is 7. So we can also substitute. which is 7. 4 plus 11 minus 1, that is 10, times 7. 4 plus 10 times 7, that is 7. And this is 74. You can check your answer in manual way by adding 7. And find the 11th term. 25 plus 11. 25 plus 11, that is 32. Next, 32 plus 7. I'm sorry, 25 plus 7, that's 32. 32 plus 7, that is 39. 39 plus 7, 46. 46 plus 7, 53. Right? Next, 53 plus 7, that is 60. Next, 60 plus 7, 64. Then, 67. And last, 67 plus 7, 74. And that is our 11th term. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, which is the same in our formula. So we have now two different formulas, the common difference and the nth term formula. An is equal to a1 plus n minus 1 times the common difference. That is arithmetic sequence. And now let us proceed to our last part, the arithmetic series. Maybe you are familiar with this question. What is the sum of the first 100 counting numbers? That is 1 plus 2 plus 3 plus the ellipse sign, 98 plus 99 plus 100. Okay? Notice the problem. Find the sum. To find this, we need to add the first term plus the last term. Notice that it has a total of 101. Next, second term to the second to the last term. 2 plus 99. That is 101. Next, third term to the third to the last, that is 101. So notice that 101 times, how many pairs do we have? 50. And that is 50. So in this method came our SN formula, or the arithmetic sequence, the arithmetic series denoted by the formula SN, which is A1, the first term, plus AN divided by 2 times the number of terms. Now let us find the sum of the first 150 counting numbers. So that is 1 plus 2 plus 3 plus the ellipse sign plus 148 plus 149 plus 150. We have, following the formula, we have the SN. Since we're looking for the 150 terms, so we have S150 is equal to A1, which is 1, plus AN, the last term is 150, divided by 2 times number of terms. We have 150. 150 plus 1, that is 151. Times, use cancellation method. 150 divided by 2, that is 75. To find the product, 151 times 75. Let us multiply. 151 times 75. 5 times 1, 5. 5 times 5, 25, carry 2. 5 times 1, 5 plus 2, 7. Then 7 times 1, 7. 7 times 5, 35, carry 3. 10. So this is add 5, 12, carry 1, 3, carry 1, 1, 1. So 1, 1, 3, 2, 5. So if you're going to add 1 up to 150, the sum is 11,325. That ends our arithmetic series. So we are done in your lesson 1. Under the arithmetic sequence, we have the formula for the common difference, that is A2 minus A1. And for finding the terms, that is AN is equal to A1 plus N minus 1 times the common difference. And for the arithmetic mean, that is A1 plus A3 divided by 2. And for the arithmetic series, the SN, that is A1 plus AN divided by 2 times the number of terms, N. So those are the different formulas that we're going to use. Now let us check your understanding. Let's try some different examples from your lesson 1. Number 1, what is the common difference of the arithmetic sequence 5, 8, 11, 14? So the formula is D is equal to A2 minus A1. A1, A2. So A2 is 8 minus A1 is 5. The difference is 3. So the common difference is 3. And now second example. What is the 19th term of the sequence 3, 10, 17, 24, 31? Let us use the formula AN is equal to A1 plus N minus 1 times D. We're going to find A19. So A1 is 3 plus N minus 1. Our N is 19 minus 1 times D. What is D? A2 minus A1, that is 7. 3 plus 19 minus 1, 18 times 7. 3 plus 18 times 7. 8 times 7, 56. Carry 5. 7 times 1, 7 plus 5, 12. So 3 plus 126. The sum is 129. So A19 is 129. Insert 3 arithmetic means between negative 18 and 4. So first let us illustrate. Negative 18, then 3 arithmetic means 1, 2, 3, then 4. That means this will be A1, A2, A3, A4, and A5. We're going to find A2 to A4. Let us find the common difference. To find that, let us use the formula for the sequence. AN is equal to A1 plus N minus 1 D. Our last term is 4. Is equal to, our first term is negative 18. Plus, N is, we have 5 for the last term, minus 1 times the common difference. Transpose negative 18, that will give us 4 plus 18 is equal to 5 minus 1, 4 times D. 4 plus 18, that is 22, is equal to 4. Now, divide by 4. 4. Then D is equal to 11 over 2. So D is 11 over 2. Medyo tricky siya. So, i-add natin dito. So, A2 is equal to negative 18 plus 11 over 2. So, sagot natin, copy denominator, then 2 times negative 18, negative 36 plus 11. Negative 36 plus 11, that is negative 25 over 2. So, ang A2 natin is negative 25 over 2. A3 natin, negative 25 over 2 plus 11 over 2. So, copy, they have similar fraction on the same denominator to negative 25 plus 11, that is negative 14. Divisible? Yes, so that is negative 7. Now next, A4. Negative 7 plus 11 over 2. So that is 2. 2 times negative 7. That is negative 14 plus 11. Now, negative 11. Negative 14 plus 11. This is negative 3 over 2. And now our A4. So our A2 is negative 25 over 2. A3 is negative 7. And A4, negative 3 over 2. That ends our first lesson. I will attach some exercises at the end of the video. And you can try those questions and check your understanding. Thank you. Don't forget to like, follow, comment, share, and subscribe to your Pablo TV.